Welcome for this lesson. We're going to look at radioactivity questions, and we're given part A that thorium-234 is a radioactive element with a half-life of 24 days. Calculate the time taken by 1 gram of it to decay to 1 out of 8 grams. Then part 2, we're told that radon-219 has a half-life of 4 seconds. Determine the fraction of it that will remain after 20 seconds. And finally, we have uranium emits an alpha particle to become another element X, as shown in the equation below. Then we are told to give the values of A and Z. So we can start solving part A. We are told that thorium-234 is radioactive. Then the half-life is 24 days. We calculate the time taken by 1 gram of it to decay to 1 out of 8. We can use two alternatives here. We want the decay to occur until the fraction remaining becomes 1 out of 8. Therefore, here we can say we have first of all 1 gram. Then because our half-life is 24 days, after 24 days, we will have it becoming a half, and after another 24 days we will have it becoming a quarter, and after another 24 days we will have it become 1 out of 8. Therefore, you realize the time taken for this series of a reaction to take place is 24 3 times, and this means 72 days. This is the time taken. Apart from this approach, we can use the nuclear reaction equation, which says that the remaining fraction is usually given by original fraction or original number times half raised to n, where n is the number of half-lives. Therefore, we want the decay to occur until the remaining fraction is 1 out of 8, and we can see it is from when the gram is full, half raised to n. So this means we can express 1 out of 8 in terms of half, and this is half cubed, which is equal to half power n. And since the numbers are the same, or the bases are the same, we can equate the indices here and say n equals to 3. Therefore, the number of half-lives is 3. And if the number of half-lives is 3, and each half-life is 24 days, then we're going to get 72 days of activity. This is what is going to be taken for the sample to decay until it is an eighth. Then we have another question which is asking about radon-219 as a half-life of 4 seconds. Determine the fraction that will remain after 20 seconds. We can again follow the reaction series, whereby we will say if the fraction starts when it is full, what fraction are we going to have after 20 seconds? So in the first 4 seconds, it becomes half, because the half-life is 4 seconds. In the next 4 seconds, it becomes a quarter, and in the next 4 seconds, it becomes 1 out of 8. In the next 4 seconds, it becomes 1 out of 16, and in the next 4 seconds, it will become 1 out of 32. So it is becoming 1 out of 2 after 1, 2, 3, 4, 5 half-lives each 4 seconds, which means this is 20 seconds. Therefore, after 20 seconds, we can see it is becoming 1 out of 32. Therefore, the fraction is 1 out of 32. Therefore, we are counting the number of half-lives until they give us 20 seconds, and now we can see the fraction is 1 out of 32. Similarly, we can say that the remaining fraction, this is alternative, Alternatively, we can say n is given by original 10 times half raised to number of half-lives. So the remaining fraction is going to be, if it starts when it is 1 out of 1, then we raise to half raised to. Number of half-lives can be given by the total time, which is 20 seconds out of half-life, which is 1, so that you may know the number of half-lives taken. Therefore here we will say that n is equal to 1 out of 2 raised to 5. And when we have 1 out of 2 raised to 5, it takes us to 1 out of 32. Therefore, the remaining fraction is 1 over 32 after 20 days, which are equal to 5 half-lives. Finally, we have a part C, which says that uranium-23892 emits an alpha particle. What we should understand here is that what does it take to emit an alpha particle, or what generally is this? So what we should know is that uranium-23892, for it to become X, it is losing an alpha particle, and an alpha particle is an helium particle. An helium particle is written with a mass number of 4 and an atomic number of 2, such that now in the mass number the element has lost 4, and in the atomic number it has lost 2. So this one has become 90, and on the other side it becomes 234. So that on both sides of the equation, on both sides of the nuclear equation, we should be having mass number totaling to the mass number on the other side. So a student must understand that losing an alpha particle means losing an helium particle, and on the other side, losing a beta particle means losing an electron. So the two should be differentiated. So this means now A is equal to 234 and Z is equal to 90. So that is how we solve the nuclear equation and get their known atoms. Remember to subscribe to this channel and share the link with your friends. Refer as many friends as possible to shifting grades. Thank you very much.